Carbon-12 and carbon-14 are two isotopes of carbon. State the number of electrons in a neutral atom of carbon-14. Well, in a neutral atom, the proton number is also equal to the number of electrons, so the answer is 6. State the number of neutrons in a neutral atom of carbon-14. Well, the nucleon number, which is 14, minus 6, the proton number, is going to tell us how many neutrons we have. So the answer is 8. Carbon-14 decays by beta minus emission. Complete the following equation below. Well, beta minus, it's not a nucleon, so the top number is 0, and it's negatively charged. So what number minus 1 equals 6? Well, it's 7, and then that's going to be 14. So 14, 7, N, nitrogen. Cesium 137 is a byproduct of nuclear fission within a nuclear reactor. Complete the two boxes in the nuclear equation below to describe the production of cesium 137. So, what we need to do is have a look at the nucleon number. The total nucleon number on one side is equal to the nucleon number on the other. And the proton number, the sum of the proton numbers on this side should equal the sum of the proton numbers here. So if you look at uranium, we've got 92 plus 0, and we want to find out rubidium, so minus 55. This is going to tell us our missing number, which is equal to 37. Uranium decays into thorium by emitting an alpha particle. The thorium product itself is radioactive, and that also decays by beta minus emission into element X. Complete the nuclear equation below, ensuring that all symbols have the appropriate nucleon and proton number. So if it's had an alpha particle emitted, well, that's 4 and 2. So uranium is 92, which is 90 plus 2. And then it's going to be uranium 238, because 238 is equal to 234 plus 4. And then let's have a look at the thorium. Well, that undergoes beta emission, so we've got minus 1 here and 0. So 234 is not going to change, but it's actually going to become 91, which, checking my periodic table, is protactinium. Carbon-14 is a radioisotope with a half-life of 5,700 years. What's meant by the term half-life? Well, half-life is the time taken for half the radioactive atoms to decay. Phosphorus 3215 is unstable and decays by beta emission to sulfur S. Write down the nuclear equation for this decay. So we're starting off, well, I'm going to write it bigger here, 3215P. That's going to go to, well, they tell us it's sulfur and beta. So we've got minus 1 and 0 here. This is going to remain 32. And this number down here, the proton number, it has to be 16. 16 minus 1 is equal to 15. Tritium, hydrogen 3, is an emitter of beta particles. Complete the equation for this decay. So tritium is 3 and 1, and it's going to become helium, which is 3 and 2, and then we're going to have 0 here and minus 1, because 2 minus 1 equals 1. Explain the term isotope. Well, it's an atom with more neutrons, but the same number of protons. Radioactive decay is a random process. Explain what this means. Well, it means the decay cannot be predicted. The diagram shows the path followed by one alpha particle when it passes close to the gold nucleus, N. Add arrows to the diagram at point X and Y to show the direction of the force on the particle when it's at each of these points. Well, X is going to experience a force in this direction, and then Y is at what point Y is going to experience a force in this direction. There we go. The diagram below shows the principle of the smoke detector. Radiation from the source ionizes the air between the plates, and a small current is detected. If smoke enters the detector, the ions stick to the smoke particles, reducing the current and triggering an alarm. Americium-241 is an alpha emitter. Explain why an alpha emitter is a suitable source for this apparatus. Well, two reasons I can think of. Alpha is highly ionizing. In fact, it's the most ionizing radiation. But the second point is it's easily blocked. So when the smoke particles get inside here, the alpha is going to be slowed down and stopped. So when the alpha comes through, it will just be stopped by the smoke particles. It won't be able to ionize the air, and therefore the current will be reduced and the alarm will trigger. Complete the equation to show the missing nucleon and proton numbers. Well, alpha is 4 and 2. And aluminium, well, 2 plus something makes 15. So 13 plus 2 makes 15, and then our neutron is neutral, so that's fine. And then the nuclear number, we've got 30 plus 1 on this side, that's going to equal 4 plus x, whatever it is. So x is going to equal 31 minus 4, which is equal to 27. So therefore, it must be 27 here. Carbon-14 is formed in the atmosphere when a particle, X, collides with an atom of nitrogen. Complete the equation to show the missing nucleon and proton numbers. Well, we've got 14 plus 1. We're going to have 1 here and 1 here. So what is X? Well, X is neutral, but it has a nucleon number, therefore it's a neutron. And Y, it's got 1 proton number, and it is a nucleon, so Y is a proton.